All right, good morning. This lesson that I'm going to do is for B Honors. So this is 6.2F lesson. Been trying to get the right lighting in my house, but I don't know if this is the best ideal. Okay, so we're going to work on solving equations using squares and nth roots. So the first question is, what does an inverse operation do? So if you think about like inverse operations like plus and minus or multiplication and division. So an inverse operation sort of undoes, I don't know if undoes is a word, I can put can undo the other operation. So just like if you add something to both sides of an equation, it undoes the subtraction. Or if you multiply something by both sides of an equation, then you can divide to undo the multiplication. So consider the equation x squared equals 25. Is 5 the only solution? Is 5 the only number that makes this equation true when substituted for x? Well, I have x squared equals 25, but what I'm looking for is x. So the inverse operation for squaring something is taking the square root. So I'm just going to go ahead and do the inverse operation. But whatever I do to one side, I have to do to both, right? So it seems like x would just be, well, the square root of 25 is 5. But the question is 5 the only number that makes this true? Well, we're going to check it. So 5 times 5 equals 25, but also negative 5 times negative 5 equals 25. So really, this actually has two square roots. We'd call the positive the principal square root. And then we also have negative 5 times negative 5 equals 25. So we'd say that actually x equals positive and negative 5. So you can write it like that, or you can say x equals 5 and negative 5. Okay, so consider the equation square root. So actually the answer up here is no, because you have 5 and negative 5. So consider the equation square root of x equals 5. Is 25 the only solution? Is 25 the only number that makes this equation true when substituted for x? Okay, so I have square root of x equals 5, but I have square root happening. The inverse operation is to square both sides. So when I square the square root of x, it undoes it, right? Inverse operation. And if I square 5, I get 25. So yes, 25 is the only solution. So go ahead and write the inverse operation used to solve each of the following equations and then solve each equation. So here I have x squared equals 100, but I just want x by itself. So if squaring is happening, then I need to take the square root of x squared. So I'm going to go ahead and do the inverse operation, take the square root, both sides. So I have x by itself equals, well, 10 is the obvious solution, but also negative 10. So you can see that 10 times 10 equals 100, and negative 10 times negative 10 also equals 100. So x equals both of those. But again, you can write it like x equals positive and negative 10. It just means both the positive and negative version. All right, over here I have x squared equals negative 36. So I can take the square root again, of x squared. So I'm going to go ahead and do the inverse operation. So on this side, I get x. But on this side, there's no number that I can multiply by itself to get to negative 36. So actually, there's no solution. If you remember in 6.2e, we were talking about how when you have an even index, you can't have a negative radicand. So no solution. There's an even index of 2. All right, here you have square root of x equals 9. So the inverse operation would be to square the square root of x. So I'm going to go ahead and do the inverse operation. Square both sides. This squaring undoes the square root, so I have x by itself, and then 9 squared, which is 81. And that's the only solution. X equals 81. I'm going to do the same thing over here. Square root of x. So square both sides, because you have to do the same thing to both sides. So I have x by itself equals, well, I have negative 8 times negative 8. So x would equal positive 64. And that's the only solution. All right, so we're going to solve these equations by using inverse operations. And our goal is to get x by itself. So express your answer in simplest radical form. Remember, this is SRF, where you follow all 3 rules for simplest radical form. Okay, so on the first one, we're going to do the inverse operation, which is taking the square root of both sides. So I have x equals, but then there's no number I can multiply by itself to get to negative 64. So this is actually no solution because I have an even index here, right? I'm trying to take the square root. Okay, number 6. Now I want to get the radical by itself when I solve an equation. So I'm going to first divide by 3 so I can get radical square root of y by itself. I'm going to go ahead and divide by 3 on both sides. Okay, so now I have square root of y equals 1/3. Now I'm going to do the inverse operation, square both sides. So I have y, because the square undoes the square root, equals 1 squared, which is 1, over 3 squared, which is 9. That's my only solution. Okay, over here I have a squared equals 1/8. I want to go ahead and undo the squaring. So I'm going to take the square root, which is the inverse operation. And then I have a equals square root of 1/8. So that's not a perfect square. So I'm going to go ahead and split that up into square root of 1 over square root of 8. Well, square root of 1 is 1. And square root of 8, if you remember from us doing square root of 8 so many times, square root of 8 is 2 radical 2. But, so this is an answer, right? I can multiply 1 over 2 radical 2 times itself and get to 1/8, but also the negative version. So actually, I can have positive and negative here. So I have positive and negative 1 over 2 radical 2. Or you can list the positive and the negative. It's not that the numerator is positive and the denominator is negative. It's just positive 1 over 2 radical 2 and negative 1 over 2 radical 2. Okay, for number 8, I want to go ahead and let me adjust my camera a little bit. Okay, I want to get the x squared by itself first. So I'm going to go ahead and do inverse operation of addition, which is subtraction. So I have 3x squared equals 90. And then divide by 3, inverse operation of multiplication. So x squared equals 30. And then I want to take the square root of both sides, another inverse operation. So 30 doesn't have any any perfect square factors in it. Like that's as simple as it gets. But I have positive and negative. So I'm going to put x equals positive and negative root 30. Okay, over here I have b squared minus 5 equals 59. I'm going to go ahead and add 5 to both sides. So b squared equals 64. And then take the square root of both sides. Inverse operation. So I have b equals actually positive and negative 8. Over here I want to get the radical by itself first. I'll go ahead and subtract 4. So I have square root of x equals 5. Square both sides. Inverse operation. And I get x equals 25. And that's the only solution because I just have 5. I'm going to multiply it by itself, get 25. Let me fix this screen over here. There we go. All right. So consider the equation x cubed equals 27. Is 3 the only solution? Is 3 the only number that makes this equation true when substituted for x? Well, I guess the other option would be, could x cubed equal 27 have negative 3 as an answer? That's really what it's asking, right? Like, is 3 the only number, or could I use negative 3? Well, let's check. So I have 3 times 3 times 3 equals 27. So x could be 3, which is also in the statement. But let's try negative 3 times negative 3 times negative 3. So negative 3 times negative 3, positive 9, times negative 3, negative 27. Okay, so this doesn't work, right? This is not going to be 27. So yes, 3 is the only solution. Okay, so let's solve these are all cube roots. We're going to go ahead and solve these equations. So x cubed equals 64. I'm going to do the inverse operation, which is actually taking the cube root of both sides. So I have x by itself, and then I have cube root of 64. Well, if you remember what we did in 6.2e, go ahead and find what the cube root of 64 is. Divisible by 2, 32, divisible by 2, 16, divisible by 2 is 8, divisible by 2 is 4, divisible by 2, 2. So I'm looking for groups of 3, right? So I have a group of 3 right here. I have another group of 3 right here. So those both come out. So x equals 4, right? 2 times 2, which equals 4. So that means that 64 is a perfect root. Now, is negative 4 a solution? Well, if I multiply negative 4 times negative 4 times negative 4, I will get negative 64, not 4. So 4 is actually my only solution. Number 13, I have cube root of x equals negative 2. I'm going to go ahead and cube both sides because that's the inverse operation of taking the cube root. So this 3 undoes this index of 3, so I end up with x. Move this over a little bit. Okay. And negative 2 to the third root, be careful with this. This is negative 2 times negative 2 times negative 2. So x equals negative 2 times negative 2, positive 4 times negative 2 is negative 8. So remember, you can take a cube. If you plug back at negative 8 back in for x, remember you can take a cube root of odd index. So this works. X equals -8. Cube root of -8 is -2. Okay, we're going to take the inverse operation again, which is, actually I'm going to write it again because I think it gets a little crowded in there. Okay, so I'm going to take the cube root, both sides. So I have x equals, because that undoes each other, right? Okay, let's figure out 135. So 135, well, 1 plus 3 is 4, plus 5 is 9, which means that 3 goes into it, right? So I have 3, 45, 3 goes into that, 15, 3 goes into that, 5. Okay, I'm looking for a group of 3s, and that's what I have right here. I have a group of 3s. So I have 3 on the outside, and then this lonely 5 left in here. But I need to make sure that I still put my index in there because I have a cube root. All right, I'm gonna do the inverse operation over here also. Again, I think I'll write it. It's a little crowded. Okay, I'm gonna do the inverse operation. Take the cube root of both sides. So I have x equals, and then we want to just figure out what the cube root of 128 is. Well, it's divisible by 2, right? So that's 64. And then actually, I feel like you should be able to stop here because way back here, remember, we did cube root of 64, and we knew that it was 4. So I know if I keep working on this 64, I'm just going to get this, right? So I already know that 64 is a perfect cube. So I know that a 4 is going to come out, and then this lonely little 2 that we started with is going to be left inside. And put our, okay. You could just put C number 12 to know why you didn't continue here with 64. Okay, here I want to get the y cubed by itself. So I'm going to go ahead and do the inverse operation of division. Multiply both sides of this equation by 2. So I have y cubed equals, and then -32 times 2, I'm not squaring it, I'm just multiplying it by 2, is -64. And I want to go ahead and take the cube root of both sides. Okay, now can I take a cube root of a negative number? Well, yeah, because this is an odd index, so it's okay to take a cube root of a negative number. So I have y equals, and it's going to be, well, we know that this is a perfect cube, right? 64. So, but it's going to be -4 because -4 times -4 times -4 is 64. All right, for 17, I want to go ahead and get the radical by itself. So I'm going to go ahead and subtract 8 from both sides. Do the inverse operation. So I have cube root of x equals 5. And then go ahead and cube both sides. So I've just been doing all the inverse operations in pink. So x equals, and this is 5 cubed. So 5 times 5 times 5, 125. All right. So Juliet solved the radical equation 2 plus radical x minus 5 equals 3, and her work is shown to the right. Did Juliet solve the equation correctly? If not, explain the mistake she made and solve the equation correctly. Okay, so here she has the original problem. She subtracts 2 from both sides. That's good because she's trying to get the radical by itself. Here she has the radical by itself equals 1. And then here she adds 5. So this is where she made her mistake, right here. By trying to add 5. Like this -5 is sort of trapped inside that radical. So I can't just add it to both sides. So we're going to go ahead and start from where she left off. So, well, we can start here because that's where she sort of lost her way, right? So instead of adding 5 to both sides, we're going to go ahead and square both sides, do the inverse operation. So now I have what's left in the radical, which is everything that's in the radical. X minus 5 equals 1, right? 1 squared. And then add 5 to both sides. See, now I've sort of freed that minus 5 out of the radical, so I can actually add 5 to both sides. So I have x equals 6. So when it says explain the mistake she made, well, here she tried to add the 5 from inside the radical. Something like that. Can't do that. Sort of trapped in there. Okay, so estimate the solution for x to the 4th equals 20 and use a calculator to check your estimate. Well, x to the 4th equals 20. So what could that possibly be? Could it be, it would have to be a pretty small number, right? Like maybe try 2. So 2 to the 4th power actually equals 16. Okay, so that's not quite enough. Maybe try 3. 3 to the 4th power. So 3 times 3 times 3 times 3 is actually 81. So that's way too big. So I just know that actually it's going to be closer to 2. It's definitely in between 2 and 3, right? But it's going to be closer to 2 because 20 is closer to 16 than it is to 81. So I'm going to guess 2.2 or 2.3, something like that, something close to 2. And I'm going to go ahead and check it in my calculator. I mean, I have a graphing calculator, so it's a little bit easier to check, but I'm going to pause this for a second because my battery is dying. Okay, sorry about that. Okay, so I had a graphing calculator, so I had to use a radical to, figure out, not a radical, but 20 to the 1/4. So anyway, if I want to solve this, x to the 4th equals 20, and I want to figure out, do the inverse operation to both sides, I don't think you could do that with those basic calculators at school. So I would have x equals, and it's about 2.1147. So actually, it's really close to 2, closer than I thought. All right, let's work on this last page. Oh, is this the last page? Oh, that's not the last page of the lesson. All right, does the radical equation 6 plus radical x equal 1 have a solution? Explain why or why not. Well, I'm going to go ahead and get the radical by itself, try to solve it. So I have square root of x equals -5. Interesting. Okay. Square both sides to get the x by itself. X equals -5 times -5 is 25. So that all seems to work out, right? But I need to go ahead and I'm going to check this answer in the original equation. Okay, so my original equation was 6 plus square root of x equals 1. And I'm going to see if actually x equals 25. I'm going to see if it works. Okay, now I have 6 plus, and then square root of 25 is 5, right? Equals 1. So 6 plus 5 is 11, which doesn't equal 1. So This, remember I told you that this is the principal square root? So if the principal square root doesn't work in original equation, then the equation has no solution. No solution. So even though it seemed like this had a solution of 25, it actually didn't work out, right? So now you might be looking at this and thinking, all right, well, 6 plus square root of 25, and I used 5 as the square root of 5. But, you know, square root of 25 also is negative 5. Well, if I use negative 5, it would have worked out, right? 6 plus negative 5 equals 1. But I need to make sure that the principal square root, the positive square root works. And so that's when I have to check on all these problems down here. I'm only checking the positive root. Okay? All right. So solve the equations below. Express your answer in simple stratical form. Show all of your work and check your solutions. You have to check your solutions on these. So you get your radical by itself first. So go ahead and do the inverse operation. Add 5 to both sides. So I have 7. Radical of x plus 3 equals 14. Go ahead and divide by 7. Get the radical by itself. So I have square root of x plus 3 equals 2. I'm going to square both sides. And then I have x plus 3 equals 4. And then I get x equals 1. All right, now I need to check it in the original equation. So I have 7 square root of x plus 3 minus 5 equals 9. I want to see if that works. And I'm plugging in 1 for my x. Okay, so I would just do order of operations. 7 times square root of 4, right? Minus 5 equals 9. So 7 times 2, right? Square root of 4 is 2. Minus 5 equals 9. 14 minus 5 equals 9. Okay, that works out. So that means that x equals 1 is my solution. All right, I'm going to go ahead and work on this problem. Oh, but would negative 1 work here? If I had negative 1 plus 3, that would be square root of 2. And 7 times square root of 2 minus 5 is not 9. So it's just 1. All right, so now I have 2/3 minus 4 radical x equals 2. Well, I don't really like to subtract fractions. You could do that. You could subtract 2/3 from both sides, but I'm just going to go ahead and multiply this whole equation by 3 just to clear the fraction. So now I have 2 minus 12 radical x equals 6. And then I'm going to subtract 2 from both sides. So I have negative 12 root x equals 4. Divide both sides by negative 12. I get square root of x equals negative 1/3. Let's go ahead and square that to get x by itself. And I get x equals, so negative 1/3 times negative 1/3 would be positive 1/9. Okay, so I'm going to go ahead and check this. So in my original equation is 2/3 minus 4, and then I'm going to go ahead and put my 1/9 in here for x. And I want to know if that equals 2. So go ahead and put 1/3. Okay, so square root of 1/3. So I have 2/3 minus, now let's figure out this square root of 1/3 situation. So I have 4 on the outside, but then the square root of 1/3 is, well, actually, we'll just go ahead and get the radical by itself first. Oh wait, I put one, oh sorry, 1/9 is my answer. Oops, sorry about that. I wish I had white out. 1/9. 1/9. Okay. So I have 2/3 minus 4, and then square root of 1/9 is actually 1/3. Sorry about that little mess up. And then 4 times 1/3 is 4/3. So 2/3 minus 4/3 equals 2. And 2 minus 4, negative 2/3 equals 2. Well, that's not true, right? Okay, so this has to be no solution. So even though I got 1/9, and then I plugged it back in for my x, it didn't work out. So this is no solution. Okay, number 23. So we're going to go ahead and cube both sides, do the inverse operation. So I have b plus 5, right? Because this 3 undoes this index of 3. Negative 2 to the third power is negative 8. I'm going to go ahead and add or subtract 5 from both sides. And I get b equals negative 13. So I want to go ahead and check it. So I have cube root of negative 13 plus 5. And I want to know if that equals negative 2. So this is negative 13. Okay, so I have cube root of negative 13 plus 5 is negative 8. And we already know that the cube root of negative 8 is negative 2. So since that works out, then this is my solution. Okay, number 24. I want to go ahead and get the radical by itself first. I'm going to go ahead and subtract 7 from both sides. So I have 2/3 square root of a over 4 equals 2. Multiply both sides by the reciprocal, multiplicative inverse, so I can get rid of that fraction. So these cancel out, and I have square root of a over 4 equals 3, right? Because these cancel out. And then I want to go ahead and square both sides. So square here, square here. So this comes out, I get a over 4 equals 9, right? 3 squared. And then multiply both sides by 4 to get the a by itself. Okay, so I have a equals 36. And I want to go ahead and check to see if 36 really works in here for a, in my original equation. So 7 plus 2/3 times the square root of 36, which is the solution I got, over 4. I want to know if that equals 9. So I'm checking. So I can start the same way. I mean, well, actually, I'll just work this out. So 7 plus 2/3, and then this just happens to be a perfect square, right? 36, square root of 36 is 6. Square root of 4 is 2. So here I have 7 plus 2/3 times 3 equals 9, right? 6 over 2 is 3. And then here I have 7 plus 2 equals 9. Okay, so that works. So this is my solution. A equals 36. Ooh. All right. For this one, it's pretty easy to add 1/5 to both sides. So I'll start that way. So I have 3 root n equals 1 3/5 plus 1 1/5, or plus 1/5 is 1 4/5. Okay, and then I'm just going to change this to an improper fraction. So 5 times 1 is 5, plus 4 is 9. And then go ahead and divide by 3. Or, in essence, really what I'm doing is multiplying by 1/3. Okay, so I have root n equals, and then 9 over 15, which is root n equals 3 over 5. Go ahead and square both sides. So I get n equals 3 squared, 9, 5 squared, 25. All right, let's go ahead and check it. So it's 3 times 9 over root of 9 over 25 minus 1/5 equal to 1 3/5. I don't know. All right, so 9 is a perfect square, which is 3. 25 is a perfect square, which is 5. So I'm going to go ahead and multiply this by 3/5. Okay, do the multiplication first. 3 times 3. So 9/5 minus 1/5, 8/5. Is that the same thing as 1 3/5? Yeah, that works out. So this is my solution. Okay, I'm going to go ahead and, this is a whole root is by itself already. So I'm going to go ahead and take both sides of this equation to the 4th power. So what that does is it releases everything that's inside. So I have 3x squared minus 1 equals -1 to the 4th power. Since I have an even exponent and a negative base, I'm still going to end up with a positive number because -1 times -1 times -1 times -1 is just going to be 1. Okay, so add 1 to both sides. I have 3x squared equals 2. Divide both sides by 3. And then x squared equals 2/3. And then I want to go ahead and take the square root of both sides to get x by itself. So I have x equals, now I have, this here is positive and negative 2/3. But all I have to check is actually the principal square root. So I only need to check, positive 2/3 or square root of 2/3. Okay, and then once I check this, then I'll go ahead and make it simple stratical form if it works out, right? Because this is not simple stratical form. Okay, so I have 4th root of 3 times square root of 2/3 squared minus 1. Extend this equals -1. And we'll see if that works out. Okay, I'm going to work on the inside of this first. So I have 4th root of 3, and then square root of 2/3 squared is just 2/3. And 3 times 2/3 is 2 minus 1 is 1. Well, the 4th root of 1 is 1, which does not equal -1. So actually, this means there's no solution. So I didn't even have to work on making this simple stratical form because the principal square root just doesn't even work. No solution. Oh, that is our last page. All right. So I hope this helps you with your homework, and just make sure that if you have an equation like this, that you need to check the principal root. So this check isn't just to do more work. It's actually to see if there's no solution or problem. Okay, good luck, and I hope you guys have a great day, and I'll talk to you soon.